Ever since I started the Blender Houdini series, I never expected a lot of you guys to watch the series, but it seems that most of you are watching the Houdini tutorials more than the Blender tutorials. I guess when it comes to Blender, after you learn modeling, sculpting, animation, and maybe doing some geometry nodes, you already exhausted what you can learn with Blender. Houdini just presents new challenges and new exciting ways to do things. For example, you can't really do something like this, a grain simulation or a sand simulation like this in Blender, where particles actually pile up and self-collide with basically what we're doing here. Surprisingly, this was easy to set up. I'm always getting surprised because I've always thought that Houdini was really complicated, but it's really easy. And one thing I have to mention here is that I rendered this out in Blender because I still love Blender. I think it's one of the best applications out there, so I'm using it for the final thing most of the time. And you can see that this was rendered actually in eeveee, and it's about 3 million particles, and Blender handled it like a champ. So you can see this is nearly 4 million particles, and Blender handled it like a champ. Now playback in the viewport obviously is going to be a bit slower, but the viewport is still responsive. And look at that, the particles are textured. So I'm using an image texture here. This kind of simulation is really impossible to do in Blender without using add-ons. I'll actually leave some add-ons that you might use to do something like this. In Houdini, you can do it right away without using any extra installations. Houdini becomes really complicated if you have no experience with other applications, or if it's explained in terms of Houdini. But if it's explained in terms of Blender, it really becomes very easy. And I'm actually going to try it in this video so that you can understand what I'm talking about. This is going to be an overview of the project, showing you the concept behind what I've done and how it is easy for someone to do, especially if they have some experience with Blender and geometry nodes. If you have never used geometry nodes before, this might be a bit difficult for you to understand, but you still grasp the concepts. And if you want to learn geometry nodes, I have a course on that as well. You can check out the links in the description. It will take you from the basics to more advanced stuff. So let's jump right into this and show you some of the renders I did. If you want to know what render I used here, I've added it in the name here. So this was rendered using eeveee. Again, 3.7 million particles, and it all rendered really quickly. Here is another one. I changed the materials to a dark material, and I think it looked amazing. Great. This is another render with sand-like materials, and I also have another one here. This was in cycles, but I think I bumped up the noise too much on the materials. That's why it's a bit too noisy. Another thing was that I didn't set up any UVs for this render. That's why you might see some sliding in the textures, and that's why it's a bit too noisy, because I have a noise texture as a bump material, and it's not using any UVs tied to the particles. So the bump is sliding under the material, and I think it's more prevalent here. I don't know if this is going to show up in the YouTube compression, but yeah, the texture is sliding under the noise. So this is before I set up the UVs, but here in this render here, you can see that the UVs were set up correctly, and now there isn't any sliding or any of that. That's why I'm even able to use an image texture like this, because I set up the UVs. Now the UVs have to be set up in Houdini, and it's also quite simple. So I'm going to show you that. Let me show you some of the other renders here I did before we get into that. I've already shown you that. Yeah, this is also another one, but the noise is too much, and the texture is still sliding because I hadn't set up the UVs. Same here, but this is rendered in cycles. This is also a different setup completely, and yeah, this is the slugs. The slug tutorial is going to be part of the course. I realized it would be too hard to follow if I just did it as a single tutorial, and longer tutorials don't work very well on YouTube, so it's going to be part of the course. And also this sand tutorial is going to be part of the course where I go step by step in the Houdini Blender course I'm working on, explaining Houdini in terms of Blender. But let me show you quickly how this was set up, just to show you how simple things are. You can look at this as 3 different parts. So we have the grain creation, we have the simulation system, and we have the exporting part. So exporting this to Blender, we're using this file cache, which is basically a one-step thing. So let's go back to the top and show you how I started. So I started with a grid, extruded it up. We need to spawn the particles inside a volume. So this grid was extruded. I didn't want it to just be flat. I displaced the mesh using a mountain node, which is similar to Blender's displacement modifier. So basically, if you have a plane subdivided, you can add displacement modifier and you get some cloud texture or whatever noise texture you have, and you can displace this as you want. Actually, this was extruded, so it would be something like that. But you can see if you extrude it in any direction, it gets messy. Extrude it in the up direction, just like that. So in Houdini, that's very simple. This mountain node comes with the noise texture already in, and you can decide what attribute you want to extrude this in, so or display this in. So it would be in the normal direction. And that's why this, and since the normals are pointing in everywhere, let me first reset this. You can see we get the similar results to what we had in Blender, just pushing vertices everywhere. But if we limit this to only the up direction, we get that upward direction. Then because I want this to be a volume so that I can instance inside the volume, I fill this in using this polyfill, and then I set up some UVs. If you don't set up UVs, you start to run into this issue where the particles or the textures you apply start sliding under the mesh. So if you want to have an image over the particles like this, you have to set up the UVs, and it's quite simple. With Houdini, you can set up some auto sims. This will set up sims for you automatically. And then I can do the unwrap to unwrap the UVs. I have this quick shade to check how my texture is laid out, and you can do this easily in Blender using this is what we're setting up as well. It's our UV quick shade. So what this does is UV unwrapping the mesh and storing the coordinates on the vertices of the mesh. But Houdini considers vertices different from points, and since we want to transfer these UVs onto points, this attribute promote is just transferring the UV attribute from vertices to points, and that's what we're using here. And we're using this transfer attribute to transfer the UV data to the points, which is basically, if you look at Blender, let me set up something quickly here. Blender has a particle system which is very powerful, but the problem with it is that these particles cannot collide with themselves. So if I have maybe a bowel as a collider, it will never fill up because the particles do not collide. So do not collide with each other. They always intersect with each other. So you can see they are all taking up the same space as one another. And if I increase the life, no matter what, these particles will never pile up. Houdini, to handle that problem so that the particles can pile up, it has something called Vellum grains. That's what we are setting up to create this sand effect. And all of these nodes are what we are using to set that up. After UV unwrapping this mesh, I create a new branch here and set up this grain source, basically filling up this mesh volume with some grains. We have some force moving the particles, but mostly at the center here where our cross is, just to make the effect more interesting. So I create this selection, basically selecting the points in the middle using this group node. And you can see that I'm selecting a bunch of particles in the middle. To add a force to those particles, you have to convert that selection to an attribute. So I create an attribute called dynamic P, and I can even preview that here. I convert that selection to that attribute, and you can see basically the same selection has turned into an attribute here that I can adjust. Now I want only those particles in white to be affected by the force to move around, but you can see we have a hard edge here, so that means that the particles here will move and the particles next to them won't move, and I don't want that. It doesn't look very good, so I blur that effect a bit. I blur that result a bit, similar to what Blender uses. Blender has an attribute blur effect. Actually, if I come here, back here, basically do the same thing, create a vertex group and assign. I can set up a geometry nodes and bring up that attribute called group, so it looks like that, and I can blur the same thing using a blur node. Basically, we are doing the same stuff we would normally do. So blur that so that we don't have that harsh transition. Now, I also wanted some particles to be smaller than the others, so I set up a randomize attribute. With this node, you can randomize any attribute you want. For example, we have a p-scale or point scale attribute, and we can randomize that using that. And I also wanted to set up some random rotation for each particle so that each particle is randomly rotated. So I did that here. This time we want to randomize the orientation. It's basically the rotation. This node was for the UVs to transfer the UVs from this mesh to the points. We've already talked about that. So basically everything up to here is already things we know how to do in Blender. Blender has the same functionality we have. The only thing it doesn't do is the Vellum grains. Basically, Vellum grains are what turns particles into points that can collide with themselves and pile up as we have sand. And setting that up is quite easy. Let me actually show you here. I can use the same thing, Vellum grains. Let me get rid of this dynamic attribute so that we can see the grains. You can see that we already have the grains with just one node here. So we are turning all these points into the grains that can easily collide with each other. And if I do a Vellum solver here, we have already looked at the Vellum solver when we are creating the slugs. The Vellum system in Houdini is quite powerful. You can use it for cloth simulation. You can use it for soft body simulations like what we have here, and they're all controllable, so you can make them become slugs like these or organic, or you can use the Vellum system to create a pile of sand that you can add forces, custom forces to, like we have done here. And it's all quite easy. I'm going to explain this in more detail in my upcoming Houdini Blender course, where I basically teach Houdini as if it was Blender. Basically what I'm doing here, but in more detail, explaining step by step. So with this node, we are converting these points into grains that can collide with each other. With this Vellum solver, we can now solve the simulation, and I just need to add a ground. I'm already done. I can hit play, and we have sand. If you animate an object, for example, I animated this cross moving from the ground up like that. I imported it. It was too big. I resized it using this smart size, and then animated it with some keyframes. And if you drag this into the Vellum collision node, so Vellum has these inputs, all you have to do to turn it into a collider, just wire that directly into the collisions. It becomes a collider, and with those two nodes, you are already done. So I can hit play, and you can see that I'm now simulating the grains, and the cross is actually colliding with the grains. You can see how things are moving out of the way, and yeah, with that you are already done. But if you want finer grains, you have to go back to the grain source and reduce the point separation. So I can use 0.05, and that should give me more grains, but you can see that the size has not changed. I can scroll down to the Vellum constraint, and you can see we have a particle size, so I also have to match that so that we have the same things. Now you can come back up here to the grain source and just copy the point separation, because those are supposed to be the same values. Copy the parameter and come here to this node and paste relative reference. That way, when you change this value, so let's bring it back to 1, it automatically adjusts the particle size, and so that we have that. If that's all you need to set up some quick grains, you can just have that exported using a file cache. You just connect this to the file cache and save to disk, and import it into Blender. You have to cache it first, and then if you want to export it to Blender, you use a node called USD export. So if you want to bring in attributes like the UV, you have to add a delete attribute node and name the attributes you want to import into Blender. So for example, p-scale for the point scale, orient, force, and UV, and you need to make sure that you check this delete non-selected, so only the selected, which are these, are exported, and that way you can export. Now the UV attribute in Blender is imported as let's select this, is imported as the ST, and that's what I'm using here, and that's the UVs we set up in Houdini. I have some custom forces, so it's not just sand laying down. I have this custom force that rotates around, that makes the grains rotate. Basically, that's it. If you want to learn how to make the custom forces, I'll just put that in the course I'm working on. Just to recap, I remember where we started from. This entire setup is driven by 4 parts. The first one is creating a mesh that will contain your grains or the shape of the grains, and fill that with grains and create some groups where you want which parts you want to move, and then set up a random scale for the particles and a random rotation for the particles. If you want some UVs, create UVs and then transfer them to the points, turn the points into grains, and then to actually simulate the grains, you can go the easy route of just using a Vellum solver where everything is set up for you. Then you have something to simulate already. You can have an animated character walking through. Let me actually get something like a test dummy. We have this graph geometry, looks like this. It's animated walking, so I can bring that in here as a collider and just take a look at that. Let me just transform it. So this could be a character imported in from Blender. You move it in and you can see just like that. You model the character, animate it in Blender and import it in and just add it as a collider, and everything works right away. Or you can go the hard route of creating your own Vellum network. This is what Houdini sets up for you if you use this Vellum solver. But if you create a dope network, you basically starting from scratch with an empty network and set up everything here, including gravity, drag forces, a ground plane, static objects. This is still very simple to set up, and I'll explain it more in my course. Or you can look at my previous Houdini Blender video that I did when I was showing off the slugs. I think I used something similar to this. I set up something similar to this, and you only have to learn this once, and you will see that it's similar for creating fluid simulations, smoke simulations, and everything else. Basically set up the same thing. So if you learn it one time, it's going to be much easier and reusable in other areas. That is set up a force that makes things animate in this spiral form, and so I'll talk about that in the coming course. All links are going to be in the description, including the project file if you want to get it. You can also check out my Blender Geometry Nodes course. It makes learning Houdini super easy. Thanks for watching. See you in the next video.